Okay, so we are in the sequence packet on day 4 or 5 of this. We are going to add parts of sequences today, which makes them called a series. So this should be worksheet 5A, is that right, guys? Arithmetic sequences are formed when the same numbers added to each term to make the next term. The constant amount being added is called the common difference. We should have this vocabulary down already. The common difference is found by subtracting any term from the term that follows it. To calculate the nth term of an arithmetic sequence, we used this formula that was on the reference sheet, and it was called explicit. Arithmetic means. Okay, so this is new vocabulary. Please make sure you understand this vocabulary because it does ask about this on the next quiz. Arithmetic means are terms between two non-consecutive terms in an arithmetic sequence. It just means missing terms, okay, in an arithmetic sequence. So, for example, yeah, this is not an arithmetic mean question. All right, we'll get to some. Find the 38th term. Anybody remember how we did this? This is review from last week. Can you tell what the difference is? What are they doing every time, guys? D equals positive 2. So the formula from our sheet is a sub n, which means some later term, is found by adding a sub 1, the first term, plus the difference, n minus 1 times. This is the common difference. This is just review or new for people who weren't here. Common difference, and n is the term number. So if we want to find term 38, we say the first term was -7, the difference was positive 2, and we're going to need to add that 37 times, or 38 minus 1 times. So we'd have -7 plus 2 times 37. I'm doing this without a calculator, but I got 67. Anybody? Did I do that right? Okay. You should be able to just type it in just like this as well. Questions? Remember those? Okay, did I cover the vocabulary enough? Just giving pause so the people who are gone have time to write it all down. This is supposed to say common difference. Sorry, it was really messy. You good? All right, write an arithmetic sequence that has 3 arithmetic means. Here's that new vocabulary. Between 3.2 and 4.4. It just means 3 missing terms, guys. So the way I taught this in the past was we just wrote down this, 3 blanks, and then we thought about what happened to get in between. So they added 1 difference. Remember, this is arithmetic, so they're adding 2 differences, 3 differences, 4 differences to get there. Does that make sense? So 3.2 plus 4 differences became 4.4. Can you solve that? And then you go back and add that difference to find those missing terms. Anybody else get point 3? So what would the missing terms be? 3.5, 3.8, and 4.1. Did I do that right? Okay. So you've got that in your head that arithmetic means just indicates missing terms, okay? In an arithmetic sequence, meaning we added. So when we added to find 3 terms, we actually had to add the difference 4 times. I'm never going to make that amount so big that you can't just write it out and do like I did with the little loop-de-loops to figure out how many differences, okay? I'm not ever going to say, find the 72 missing terms, okay? All right, write an arithmetic sequence that has 3 arithmetic means between 17 and 39. All right, I'm going to actually pause the video and let you guys try this one on your own. So 3 missing terms. All right, so if there was 3 missing terms, I figured out that meant 4 differences had to be added. We subtracted, divided, and got 5.5 or 11 halves, I think. But it's an exact decimal, so I'll just be easy peasy and use the decimal here. So 17 plus 5.5, 22.5, guys. Plus 5.5 would be 28. 33.5, 38, 39. That seems right. Seem okay? All right. Write an arithmetic sequence. Oh no, I just said I wasn't going to do too many, but have we got a pattern down in our head right now? -2 plus how many differences would get us if we were to find 7 missing terms? 8 differences. It's not that horrible on the quiz. That's painful to try to write out 8 or 7 missing terms. Let's see, if I add 2 over there, I get 18. Divided by 8 would be 9 over 4 or 2.25. Anybody? Okay. I think I'll do this one as fractions. You don't have to. But it would be -2. I'll show you a little trick. -2 plus 9/4, enter, plus 9/4, math, enter, enter. And then I should be able to just keep pushing enter and it'll give me the rest of the terms. Okay, so now I got to scroll back up and see what it was. 1/4, 5 halves, no, yes, 19/4, 7, mm, 37/4, 23 halves, 16. Did I get them? 1, 2, 3, 4, 5, 6. Nope, one more. 55/4, and then 16. That was a disgusting question. All right, I do hereby solemnly swear that will not be on the quiz with that many missing terms. Yes. Yes, because it's exact, I would be fine with decimals. Yep, good question. If it was a repeating decimal, then you'd be better as fractions because I don't want you to round. All right, an arithmetic series, okay, new vocabulary, is the sum of the terms of an arithmetic sequence. You can use a formula to find the sum of a finite arithmetic sequence. Finite means it ends. It's also called the partial sum because you're adding up a certain number of terms. So using the first and last terms and the formula S sub n equals n over 2 times a plus 1 a plus n. Does that look a little different on your reference sheet? Yes, well, it has 2 versions on your reference sheet. This is the one that Delta Math uses, But do you see that it's the same whether you take n divided by 2 and then multiply, or take n, multiply, and then divide by 2? It's all the same difference, okay? But you have to have the first and last term. So one more time, this is the first term, and this is the last term, whatever n is. And then n is the term number. Be very careful. That's where the most common mistake using this formula is people forget what n is supposed to be. Everybody got what they want written down? All right, so find the sum of the first 50 terms here. This one is kind of a gift because they've given us the first term and the 50th term. So this is a sub 1, this is a sub 50, and they're told us we're finding the sum of the first 50 terms. So this is n. So we're going to use the sum of the first 50 terms is the term numbers that we're adding up, number of terms we're adding up, divided by 2 times the first term plus the 50th term, okay? Let's see, what were we adding? 3? I just want to guarantee that that's the 50th term. It would have been 11 plus 49 times 3. Somebody check in that to make sure that's 158. I think it is, yes. So this was just checking that we had term 50. All right, so to find the total sum, we would just do 50 divided by 2 times, what is it, 11 plus 58, guys? Thank you. 1725, anybody? Oh. Of course it was. 158 parenthesis 4225, better? 4,225. Okay, now sometimes they don't give us the last term, or it's possible they don't even tell us how many terms we're supposed to find. They have to give us one or the other, but example 4 says, find the 23rd partial sum of the geometric sequence. So they want us, this means the sum through 23 terms, okay? That's just the wording for it. So we need to find the last term that we're going to want in our sequence. So we need to find term 23, sorry. And how do we ever find term 23 in an arithmetic sequence? What's the formula look like? Okay, so we're using n equals 23. What's D? Negative 9? 11? Yes, negative 11. Okay. So, and term 1 was 173. 173 plus negative 11 times 23 minus 1. I got negative 69. Anybody else get that? Now what? How do we find the sum through 23 terms? What's n? 23 over 2. A sub 1 is 173. And a sub 23, or the last term, is negative 69. So 23 divided by 2 times, I already forgot, 173 minus 69. 1196, anybody? Or everybody? Okay, so as long as you have the reference sheet, this seem okay so far? All right, find the 82nd partial sum of this series. So somebody tell me, what is n? 82. And to find the 82nd term first, we need the first term, which is -1, plus, what's the difference? -3 times, what is our n? Again, 82 minus 1, because the formula is a sub n equals a sub 1 plus d n minus 1. We're not finding the sum yet, we're just finding the 82nd term. 81 negative 240, is it negative 244? That's probably wrong. Okay. And so now how do we find the sum? Somebody? 82 over 2 times, yep, -1 minus 244 plus negative 244. I didn't explain why this works, and it's really kind of cool. Oh, can't type. I got negative 10,045. Anybody else get that? No? Oh. Anybody not getting that? Okay, let me real quick, I should have talked about this before, explain how this works. If I asked you to add up all the numbers 1 to 100, there's a really easy way to do this. Guys, look what happens when you add 1 and 100. It's 101, right? When you add 2 and 99, it's 101. When you add 3 and 98, it's 101. So there's 100 terms. If we cut that in half so that we're getting pairs, and every time we got 101, so it's 50 iterations of 101. Does that show you a little bit of how it works? So on this one, we were just doing, when you added the first and last term, that's telling you what all of the pairs of terms would add up to. And then this is how many pairs there would be. I should have started out with the explanation. All right. Find the sum of the first 25 terms. I'm assuming this is term 25. 7 plus 3, 25 minus 1, 24, 72 plus, yes, this is term 25. So that should be an easy one. Can you do that one quick? The sum of 25 terms. What's n? 25. What's a sub 1? 7. And what's a sub n? Or a sub 25 is 79. I got 1075. All right, I feel like we're coming up on some word problems eventually. This one, just one more practice. We don't know the 53rd term yet. So to find term 53, we would take what? What's the first term? Plus, what's the difference? 8. So if we want the 53rd term, we do that 52 times, or 53 minus 1. I got 428 is term 53. So the sum, (53 over 2) 12 and 428. 11,660, anybody? All right, now we have an application. Wakefield Auditorium has 26 rows. That's the total, so that's, I think, going to be our N. The first row has 22 seats. That's A sub 1. The number of seats in each row increases by 4. What's that number? D. How many seats are in the last row? What is the last row again? 26. So we need term 26 is the first term, which we decided was what? Plus the difference of 4. How many times? Yeah, 26 minus 1 or 25 times. Somebody check. I'm thinking that. 122? Okay. So what is the seating capacity of this auditorium? What is that asking us? Yeah, find all of them. Sum of the 26 rows. It should be 26 divided by 2 times the first row through the last row. Anybody get an answer? Was a good year. 1872, anybody? As though I recall. All right. That's a pretty straightforward application question, yeah? All right. The first year salary of an employee is $64,500. Each year thereafter, her annual salary increases by $3,750. What will her salary be during the 10th year of work? During the 10th year, she will have only had 9 increases, right? Which follows our pattern of n minus 1. So 64,500 is our term 1, plus the difference they gave us, and if we're looking for a sub 10, we would say 10 minus 1 or 9. Okay, I didn't write that very clearly, but 64500 plus 3750 times 9. I got 98,000 and something. Anybody else? Okay. Now, what will her total earnings be for 25 years of work? Because this is an arithmetic sequence, we can't find the 25-year total until we find the 25th year salary or 25th term. So we need to go back and do what we just did, but with a 25. 64,500 plus 3750 times 25 minus 1. Her 25th year salary. Thinking it's looking pretty good, but I got 154,500. Okay, is that the answer to the question? That's her salary the 25th year. We want her, her total earnings. So we need the sum of 25 years. How would we do that? 25 over 2 times, what was the first one? 64,500 plus the last one. Careful with all your zeros. I got 2 million. Someone get over 2 million? You guys know I'm retiring this year, but my first year's salary was under $17,000. It was under 15 maybe. It was a long time ago. My apartment also rented for $140 a month, so with 2 bedrooms. All right. Hannah gets a box of 100 chocolates for her birthday. She eats 4 chocolates a day starting on her birthday. How many chocolates does she have left after 8 days? This is not really a sum question, right? This is just a sequence question. What does this number represent? Her first amount. What does this 4 represent? The difference, but I don't think we want it to be positive, do we? -4. How many chocolates does she have left after 8 days? Now we got to think about this. So the first day there's 100, but the second day she's down to 96. I'm thinking she ate them starting on her birthday. Don't you think so? So how many differences are we actually talking about? If this is actually the end of her first day, right? End of day 1. So if we want to do it that way, we could say she started with 96 and she subtracted 4 for 8 days, or you could say she started with 100 and she subtracted 4 9 times. Am I right? Actually, if you started with this, it would be 8 times and this would be 7. Oh, now I'm confusing myself. All right, I'm going to do this the old-fashioned way. Okay, that's the end of day 1. Day 2, day 3, day 4, day 5, day 6, day 7, day 8. I got 68, so let's see what I did here. 96 minus 4, I'm thinking 8 times, or that would have been 100 minus 4, 8 times. Okay, I think it's 100 minus 4, 8 times, or 96 minus 4, 8 minus 1 times, or 7 times. Yeah, I confused myself. She ate them 8 days, so it's 4 times 8 differences from the original box. That would have made sense to me. So that was worded strangely, or Hofbauer's brain wasn't working right. What was the answer, guys? 68? Left. Okay. All right, last thing for the day is sigma notation. A series may be written using this summation. This is a sigma. It means find the sum, denoted by the Greek letter sigma. A formula is written to the right of the sigma. The first number to be substituted for the variable is given below the sigma, and the last number to be substituted for the variable is above the sigma. The results of each substitution are then added. The starting value is not always 1. There are several ways to do this on your calculator. If you have a newer calculator, it's very easy under the math menu. So you go to math and you scroll up or down until you find the summation. It looks like it's choice 0 on mine. And then you can just put in all these things. Now, depending what mode you're in, you will get a different variable, but it doesn't matter. I will go back and put my calculator in function mode, I guess. But it really doesn't matter what mode you're in. You can use any variable. So this one had an N, but that would mean I had to put it in sequence mode. Okay, why won't it let me go down and type in there? There we go. I'm going to put X equals, was it 1 to what, guys? 15? Was this question terms 1 through 15? Oh, 3 through 15. No wonder you're not saying anything. Okay, I need to make that a 3 through 15. And then in this, make sure you're between the parentheses with everything you want it to include. So you can't put extra parentheses. And then 3x plus 1 here. Now, if you had an old calculator, it would be, let's see if I can remember this. I want to say second stat over to math, choice 5, and you would get sum, and then second stat over to calculate. I did that wrong. It's second stat over to calculate. Oh, what am I doing? Oh, I'm pushing alpha. Dingbat. Second stat over to ops, down to sequence. So, then if you have the older calculator, you would do x, comma, nope, kidding. This was, what was the sequence, guys? 3x plus 1. You type 3x plus 1, comma, x, comma, was it 3 through 15? The step is we're counting by ones. You don't have to put that in, actually. And this is what it will look like on the screen, and it should give you the same thing. So, what are we going to do? If we don't have an old calculator, we're going to grab the one in the back and use the summation thing, right? It's a lot easier. Does everybody find a way to get it to work one way or the other? You actually don't need the one at the back. Whose calculator does not have the sum under math, up arrow? Who does not have this summation symbol? Math, up arrow. Does yours have it, Antoine? Everybody's is good? Oh, good. So we don't have to worry about that mess. Okay. So what did we get for this answer, guys? I forgot. I wasn't paying attention to my calculator. 364. By the way, what this sequence looked like, you would put in a 3. 3 times 3 plus 1 is 10. Then you would put in a 4. 3 times 4 is 12, plus 1 is 13. Then you would put in a 5. And you would keep going until you put in a 15. And we added up those numbers, okay? But it came out to be 364. We just used that summation notation. All right. 11 is weird because it's not arithmetic, and we have to be super careful how we type that one in. This one is 3 through 7. Anybody finish these all already? Okay, let me make sure. This one is n squared minus 2, or x squared minus 2. I got 125. And then math, up arrow, find summation. And this one is terms 1 through 6. Okay, and it's got to all be in here. So 3, 1/2, n minus 2. 3, extra parenthesis, 1/2, to the n minus 2. Make sure you stay in that parenthesis. And then 11.8125, guys? Okay. So let me put that on the screen in case somebody needs the notes. No, you should put the whole thing, because on the quiz it very specifically says exact value, or you can do a math enter. We're going to do more on that one on Wednesday, because that's actually a geometric sequence. So the practice today is much like the worksheet was. There's some old questions and some new questions and some application stuff, okay? It's in Delta Math this time. You have is there a page in there for work? Why do I feel like there was like a blank page somewhere to do your work on? Am I crazy? This one has no, it's towards the back somewhere. What is it? Worksheet 8A has room for work. Okay. And then tomorrow, I just want you to know, because some of you might have AP tests tomorrow. Tomorrow is a work day, except there is a like 7-question Google form for you to do. Okay? You could do it today, tomorrow, tonight, tomorrow night, in class tomorrow, whatever. Again, show your work and keep your paper. And it is, I believe, set up in quiz mode. So you only get one shot and you have to be on your Chromebook to do that little activity tomorrow, okay? It's not going in the summative category, but I would like you to. You're welcome to use your notes. I just don't want you Googling all the answers. So, any questions? All right.